Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we will be solving this S1 paper, which is paper 5 of the CAIE math exam. This is Mathematics 9709 and we are solving S1 paper. The variant is 52, which is the second variant. It's a walk-through solution. Look at question number 1. It says Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3 independently of other years. Part 1. Find the probability that Rajesh is successful for the first time on the 7th attempt. That means the first 6 attempts are failure and he is successful on the 7th attempt. This is a geometric probability question. So the probability of success is 0.3. It will only occur once, and that also at the end. The first 6 are failures. So there are 6 failures. So F is for failure, last one is for success, and this is the answer that you get. Second part. Find the probability that Rajesh is successful for the first time before 6th attempt. Now probability x is less than 6. Let me go to this blue box. These two are very important results that is applicable for geometric probability distribution. Probability x is lesser than or equal to n is 1 minus probability of failure raised to power of n. And if we need this thing, probability x is greater than n, that is q raised to power of n. So probability x is less than 6 before his 6th attempt. That means it could be on the 5th attempt or the 4th or the 3rd or the 2nd or the 1st. So either you calculate it all separately and add it up or just use this result. You cannot use this result directly. Why? Because this is simply less than. You need less than or equal to. So less than 6. 6 is not inclusive. Is less than or equal to 5. There is a solid circle and then you use this and then you get this answer. So now 2 parts are done. Let's focus on the third part. Very unique, very different from what we are supposed to do in an exam. Find the probability that Rajesh is successful for the second time on his 10th attempt. Now, if we are talking about 10 attempts, and this is the second time that he is successful, that means he was successful on the first attempt. Leave that thing out. Just write that probability of success over here as it is. This is binomial with a twist. And then 1 success out of 9 attempts. So now this thing is binomial. Let me highlight this. So this thing over here, this is binomial. And this 0.3 is kind of like geometric distribution on the first attempt or just a simple probability as it is. So I can say this is geometric and success on first attempt. So basically you break this up into 2 parts. So therefore it's success on the first attempt, that is 0.3, and out of 9 you need 1 success. That will add up to 2 successes in 10th attempt. So 1 attempt separate and then 1 out of 9, that is binomial, and this is also happening. So therefore we find this probability, and then we multiply. Now keep in mind that you need to control your nerves when you are solving a past paper. Well, for you, it's a present paper. Right now, you are looking and going over a past paper solution. So whenever you are in an exam, you need control of your nerves. If such a difficult or a unique question comes in, it's not necessary that you waste all your energy and all your time on a 2-mark question. Yes, the whole paper is 50 mark. Every single mark is worth it. But you can skip it for later and come back to it at the very end. Let's look at question number 2. Now, this question is about probability. The whole paper S1 that has 2 things in it. that is stats and probability. So probability is overwhelmingly present in these papers. Saver has a coin which is biased, so that when it is thrown, the probability of obtaining a hit is 1/3. He also has a bag containing 4 red and 5 blue marbles. This person throws the coin. If he obtains a hit, he selects one marble from the bag at random. So if this probability is applied, then he'll be selecting only one marble from the bag. On the flip side, if he obtains a tail, the probability of obtaining a tail is 2/3, and it's written right over here. So make sure your information is all listed down separately. You don't have to peek into the question on and off. That will create a lot of confusion because there are numbers, there are colors, there is wording over there, so that will create confusion. So that is why you should have a box ready on the side. So let me put this thing in a box like this. So this is the box for the coin. So now what is happening is that if he gets a tail, he selects 2 marbles from the bag at random and without replacement. So head is 1 marble, tail is 2 marble, and that also without replacement. Now the question says find the probability that saver selects at least 1 red marble. Now at least 1 red means exactly 1 red or more than 1 red, which is only 2 reds in this case because that's the maximum that you can select. So now if I'm interested in selecting 1 red marble, that is the first is the possibility that I'm getting a hit and then I'm getting a red. So that is the only way of selecting exactly 1 red marble. So this 1/3 is this probability. This 4/9 is out of this. There are 4 red, 5 blue marble. So now let me also make a box out of it. So 4 red and 5 blue. So these are the probabilities that we have. Probability of red 4/9. Probability of blue 5/9. So head and a red 1/3 into 4/9. Exactly 1 red. If we are selecting this option, that means we are getting a tail and then we are selecting 2 marbles at random. So it is tail, red and blue, or it's tail, blue and red. So for tail, this is the probability 2/3, that's right over here. And for the red blue, the denominator decreases, 9 decreases to 8, over here 9 decreases to 8. 4 is for red, 5 is for blue, again the order change. So I could have written it once and multiplied by 2, but I deliberately wrote it separately so that you have a clear idea of how to list things down, how to write down the possibilities, and based upon the possibilities, how to write down the probabilities. So therefore, I'm writing it all out. Exactly 2 reds. Exactly 2 reds, of course, will be based upon the tail because that's the only option of getting 2 marbles. So exactly 2 reds, that's a tail, 2/3, red and a red, 9 decreases to 8, 4 decreases to 3. So now exactly 1 red, exactly 1 red, exactly 2 reds, add up all these probabilities. That is the simplified format, and this comes out to be 136/216, which simplifies to 17/27. So that is for 3 marks. It's worth 3 marks. It's not difficult, but it's elaborate. So keep in mind, if something is elaborate in terms of working, then usually what happens is the concept is simpler. And sometimes there is very less working, but the concept is difficult. So keep this in mind that this ratio always is there. Then it says find the probability saver obtains a hit given that he selects no red marble. So now let me write it down. This is conditional probability. In conditional probability, usually the word given is there or the word if is there. If it's related to past, the word given is used. If it's related to future, we use the word if. So given that he selects no red marble, so probability of at least one red is 17 over 27. Probability of no red, I can list it separately, but I just did the subtraction. This is 10 over 27. Probability that Seva obtains a hit given that he selects no marble, that means I need an option of getting a hit and no red. That means head in blue. So head is 1/3, blue is 5 over 9, 1/3 into 5 over 9, that's 5 over 27. This 5 over 27 becomes the numerator. This 10 over 27 becomes the denominator. And basically, we can also write it in set notation. As such, there is no need if you apply the concept, but just to give you an idea, probability A slash B. Probability of A occurring given B has already occurred. That's the common probability, A intersection B, divided by probability of B. So this is the condition, this is the given thing, and this is the common thing. That's how this is done. And this answer comes out to be a beautiful half. Now let's focus on question number 3. Now this is a traditional normal distribution question. The weights of oranges can be modeled by a normal distribution with mean 131 and standard deviation 54. That's written right in this bracket over here. So let me focus on this bracket. Now there are 3 categories of oranges. That is small, medium or large. A large orange weighs at least 184 grams. And 20% of the oranges are classified as small. So what I have done is that I have drawn a number line, at least 184 grams. That means 184 or more, that is considered large. 20% of the oranges are classified as small. There is a value S. That means anything less than S will be classified as small. So S is the greatest value under which this orange will be classified as small. And if they were asking for medium, that lies between these 2 values. Now the first part, find the percentage. That means you will find the probability and you will multiply by 100, you will get the percentage. Find the percentage of oranges that are classified as large. So therefore, probability X is greater than 184. Standardize the X value minus the mean divided by standard deviation. That comes out to be this Z value. Z greater than a positive value. That means if this is the normal distribution, this is the probability that you're looking for. So we find this probability and we subtract it from 1. So I can either write it like this, or let me write over here, I can use the symbol phi. Because probability Z lesser than a value can also be written as phi of A. This is reading probability from the table. So that's how this thing is done. So now we get this particular value, which is 0.837. We subtract it from 1. This is the probability that we got. So this is probability and this is percentage because I multiplied by 100. Keep track of the significant figures. Now this thing is done. Let's look at part B. Now it says find the greatest possible weight of a small orange. So the greatest possible weight will be this value S. Lesser than S is 20%, greater than S is 80%. So probability, instead of S, I have used the symbol M. So let me go ahead and change it so that no one gets confused. So I'm writing M for this particular weight. Probability X lesser than M is 20%, or probability X greater than M is 0.80. That is how we start the working. So now this is about back solving. We standardize M minus 131 over 54 is 0.80. Based upon 80% probability, we find the Z value, that is 0.842. Now, according to the rules that I've explained, if Z has a greater sign after we have made this probability at least 0.5 or 50%, that means Z value is negative. I have just drawn a diagram to make it further clear. There is a particular value Z such that right of this value is 80%. That means this value will lie to the left of 0. Of the center line that corresponds to the Z value of 0. This value is negative. We compare coefficient Let me highlight this. So let me just use red color over here. We compare coefficient, and then what do we get? We get the value of M. That comes out to be 85.5. So that was a traditional normal distribution question. It was all good, all clear. So now let's focus on this question, which is about a representation of data. It's a back-to-back stem and leaf diagram, also known as stem plot. And it shows the annual salaries of 19 employees at each of two companies, P and R. Let's keep life simple. This is P, this is R. P is denoted by red color and R is denoted by blue color. Now this, I have done the question partially. I've already written down the answer, but I'll show you the working. Now first of all over here, 2/31/5, it means 2/31. That is over here. So let me make it simpler. This is 2 and over here this is 2 and this is 31. So 2 and 31 is over here. That is 2 from here, 31 from here. That means 2 is the leaf and 31 is the stem. So that is 31,200. That means this is basically 31,000 plus 200 from here. So this is 31,000 plus 200, that is 31,200. And similarly 31,500. So 31 and 5. So let me use blue color over here. That is this and this. So now over here, what do we observe? We observe this is 31, this is 5, that is 31,000 plus 500, that is 31,500 for a Revon employee. And what exactly is this? These are the annual salaries. Now, before we proceed, just look at all these values. And suddenly there is an extreme value in petrol. And over here, all these values are there, and these are kind of extreme values. It's asking for median and interquartile range for the salaries of petrol employees. So now what is the working that you will do? You will write 19 divided by 2. That is 9.5, round it up. That is the 10th value. Now the 10th value, it will correspond to Q2. Q2 is the symbol that we use for median. So let's count it out. So now this is 1. Let me use a different color. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, and this is 10. So 0/32, that is 32,000. So 32,000, that is your median. That's how we calculate it. So now there is a 10th value over here. There are 9 values on this side. There are 9 values on this side. Now out of these 9 values, 9 divided by 2 is 4.5. Round it up. That is the 5th value. This 5th value is the lower quartile. So let me just erase these green marks. And then let me again use, let me use a green color, a purple color. Okay. So now 1, 2, 3, 4, 5. Now this value over here, 31/2, that is 31,200. That's the lower quartile. Now let me highlight the median. That was 32,000. That was right over here. This was 32,000. And now let me calculate the upper quartile. So again, it's the 5th value out of this. So this is 1, this is 2, this is 3, this is 4, this is 5, 5/33. So 33,500, that's the upper quartile. And last but not the least, we have to calculate the interquartile range, which is upper quartile minus lower quartile. So this is lower quartile, this is median, this is upper quartile. So this minus this, that gives you the interquartile range. That's how this thing is done. Now let's look at the next page. So on the next page, it says that the median salary for our employees is this much, and this much. So this is median is Q2 and lower quartile is Q1, upper quartile is Q3, and I've added 2 more things. That's the lowest value and the highest value. So the lowest value for our company, that is 32. That means 30,200. and the biggest value is 36,900, that is 36,900. That I have written over here. Why have I written over here? Because they are asking us to represent the data shown in the back-to-back stem and leaf diagram by pair of box and whisker plot, popularly known as box plot. So that's a 5-point summary. Remember this thing, 5-point summary. That is what we are doing. So that's the marks in the middle. So what are the 5 points? That is the lowest value, the lower quartile, the median, the upper quartile, and the highest value. So let me write in the right order. So we have this thing that is, hold for a second, lowest value, lower quartile, then we have median, then we have upper quartile, and then we have a highest value. And what do we do out of this? What we do is that, let me draw a box for these three, and then we join the others like this. We join with dots, and then we make a box like this, and all these things, and that's how it's drawn. Okay, just ignore the lines in the middle. So that is for the median line is there, and then something like this. So now I have also collected the data. These three we just calculated for the petrol company, again the lowest value and the highest value. The lowest value is 0/30, 30,000, 8/36, 36,800. So that's right over here. So now when we draw a box plot, what is necessary? That the scale should be there. And what is necessary in a stem plot? In a stem plot, a key is a must. And the second thing, the class widths that are chosen, they have to be of equal class width. So these two are the conditions that's necessary. Now coming back to this idea, what are we doing right now? So we have drawn a scale. What I did is that I looked at the smallest value. So the smallest value out of all these 10 pieces of data is what? 30,200, 30,000. 30,000 is the lowest value. And the biggest value is 36,900, which is 37. So the grid that they give, that is so specific that they don't want you to go astray. So they give you the exact detail. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 big squares are there. So I've labeled this as 30, and let me write a K over here. This is 30K, 31,000, 32,000, 33, 34, and so on, and it fits exactly correct. Now based upon that, the red color is for petrol. So now I have put the dots over here. So now this dot is for lowest value, this is for lower quartile, median, upper quartile, and highest value. The same thing goes for the blue company, that is Revon. Now the first thing that needs to be done is that, let me draw a thick blue line over here, and there is no specific width for it. So even if I draw something like this, that is perfectly good. And let me draw a box around it, and it goes like this, passing through this point, and you know exactly what I've done. What I have done over here is that this point, and this point, the width doesn't make a difference. All you have to do is to make it visible. And then what we do is that we draw a line from the lowest value to the lower quartile, and from upper quartile to the highest value, and we can write the name in the middle. This is for the blue company, which is Revon. So that's how this thing is drawn. Some people, what they do is that they even draw a vertical line over here like this, just to give you an idea that this is where the buck stops and this is where you stop. So that's how this thing is done. Similarly, let me choose the other color, which is red, and let me draw a line for median of this thickness, something like this. And this is the median line. And then over here, what I'm doing is that I'm going like this, and passing through the upper quartile, making a box. Of course, you would be using a ruler, and that's how this thing is drawn. And let me choose another color. Let me choose a green color. That looks nice. So let me join these 2 points like this. Let me draw a line like this. Let me draw a line like this, and something like this. So now I have labeled this. So this is one point, that's the other point, that's the other point, and let's write the name of the company. The name of the company is Petrol. So that's how this particular box plot is drawn. Now let's look at part C. It says comment on whether the mean or the median would be a better representation of data for the employees at Petrol. Now, when we talk about a better representation of the data, basically we are talking about measures of central tendency. Sometimes they ask about measures of central tendency. Sometimes they can ask about measures of dispersion. So now when we talk about measures of central tendency, we are talking about mean, we are talking about median, we are talking about mode. Now if I compare median versus mean, so mean is a good measure of central tendency. It's based on calculation. It involves all the values. So therefore, these are the good points about mean, but there is an issue, and that issue is it is distorted by extreme values. That means the mean that we will get, it will not be realistic. Now let's first double check that for the company Petrol, is there an extreme value? So when we look at the data, this is what has been highlighted, 8/36. Now all the data is centered around here. The maximum is 1/34, which is 34,100. And then all of a sudden we have 8/36, which is 36,800. So we have this extreme value, which is 36,800. That's an extreme value. Therefore, the mean will be distorted. The mean won't be realistic. Therefore, we are left with median. When data is arranged in a particular order, preferably an ascending order, the value in the middle, that is the median. And what does median tells us? Median tells us that half of the data is below this value, half of the data is above this value. Therefore, median is a better measure of central tendency. Let's look at this question, question number 5. This is about DRV, discrete probability distribution. Actually, this is discrete random variable, also known as probability distribution. Now Jasmine has one $5 coin, so I have labeled it like this. Two $2 coins labeled in blue and two $1 coins labeled in green. So red is for 5, blue is for $2, green is for $1. She selects two of these coins at random. The random variable X is the total value in dollars of these two coins. Now it is obvious that if the selection of two coins is done, naturally this is without replacement. So keep that in mind. Now I have shown the first part and then I'll be doing the second part live in front of you. So now it says show that probability X is equals to 7 is 0.2. So 0.2 is 2 over 10 or 4 over 20. So now what I am doing is that for X is equals to 7, what is X? That is the total value in dollars. So how can I get $7? I can select a 5 from here. I can select this $2 coin or 5 and this $2 coin. That means there are two options for this one. So therefore, what I have done is that I have written 5 in the denominator, 4 in the denominator because without replacement. And there are two blue coins. So let me use this blue color right over here twice. And there is this red color for the 5. So there are two options of this one. So just look at the denominator. 5 over here, 4 over here, 2 because of 2 possibilities, 1 because of 1 possibility, and this 2 is there because it could be in either order. It could be 5 2 and this 5 2. So therefore this comes out to be 4 over 20 or 2 over 10. That comes out to be 0.2. So now this thing is done. Let's move on with the rest of the question. The same data is right over here, and there is this option of 5 2 which is already dealt with in the first part. The examiner gives us some additional support. So this answer is for checking. So now over here we have 5 1. So let me first do the setup. That is 5 and 4. That is for all of us. So this is 5, this is 4, that's 5, that's 4, that's 5, that's 4, that's 5, and that's 4. Now this thing can also be explained from this perspective. These are two different colors, different denomination of currency. So therefore there are two possibilities. So there will be two possibilities over here, two possibilities over here, two possibilities over here, but only one over here, only one over here. So the first thing is, let me write a 2 over here, let me write a 2 over here, let me write a 2 over here, and then a 1, and then a 1. The next thing is that how many $5 coins are there? So $5 is 1, $2 is 2. That is already done in the first part. I'm just writing it in a sequence. And then 5 and 1. So again 1 over here, 2 over here. So I'll put the color in a short while. And then for 2 and 1, there are two $2 coins and two $1 coins. So let me choose the color. So that's for 5, that's for 5. And then if I choose blue color, that's over here. And then blue color over here, and then green color over here, and green color over here. That is the order in which I'm doing the multiplication. And then again green and green over here, and then again a blue and a blue over here. Now keep in mind, if there are two $2 coins or two $1 coin, the same is the working. Any one of the two, 2 reduces to 1. Any one of the two, 2 reduces to 1. So let me write over here 2, 1, 2, 1. Now I'm not gonna simplify the denominator. I'll simply write a 20 over here, and then later on I'll simplify. I'll first double check whether all the probabilities should add up to 1. So that will be a check. The total probability should add up to 20 over 20 or 1. Now just multiply the numerators. That is 1 into 2 into 2, that's 4. And this is also 4, and this is 8, and this is 2, and this is 2. So let me double check. So therefore 4 plus 4 is 8, 8 plus 8 is 16, plus 2 is 18, plus 2 is 20. Yes, it adds up to 1. That means I have done it all perfectly correct. Now 2 over 20 can be written as 0.1, 2 over 20 is 0.1, this 8 over 20 is 4 over 10, that's 0.4, 4 over 20 is 2 over 10, that's 0.2, and this is 0.2, again double check. 0.2 plus 0.2, 0.4, 0.4 plus 0.4, 0.8, 0.9, 0.10, that is again 1. So now just write it down in the proper order. This is the amount in dollar. For $2, that's 0.1. For $3, that's 0.4. For $4, that's 0.1. So this is 0.1, 0.4, 0.1. So that's 0.1, 0.4, and this is, I think, 0.1 over here. Let me just do the correction. So this is 0.1 right away over here. And then what else is there? Then there is 6, that is 0.2. And then 7, that is 0.2, 6 is 0.2, 7 is 0.2. This is all good, all clear. Now it's asking for variance of x. So let me just remove this tick marks. All the working has been double checked. So now when we talk about expectation, this is sigma xp. That means take the value of x, multiply it with p, and sigma means add it up. So that's 2 into 0.1. 3 into 0.4, 4 into 0.1, 6 into 0.2, 7 into 0.2, and this adds up to 4.4. So expectation of x is 4.4. Let me make a column for x square. So this is 4, 9, 16, 36, and this is 49. So expectation of x square, that is sigma x square into p, that is 4 into 0.1, 9 into 0.4, similarly 16 into 0.1, 36 into 0.2, and 49 into 0.2. This simplifies to 22.6. Expectation of x square, that is 22.6. And last but not the least, that is variance of x, which is expectation of x square minus square of expectation of x. Expectation of x square is right over here. Expectation of x is right over here. You have to square it, use a calculator, you get this answer. That is pretty basic stuff. And the question was a nice one. Not a difficult one, but a nice one. Now let's look at question number 6. It says the residents of this particular town, no need to pronounce it, were asked to classify the local bus service. 25% classify it as good, 60% satisfactory, 15% poor. A random sample of 110 residents is chosen. Use a suitable approximation. So the only approximation that we find suitable is the normal approximation. Find the probability fewer than 22 residents classified the bus service as good. So this is the probability that we are using, which is 25% in this question. So we will first write x follows a normal distribution, binomial distribution, 110, 0.25. N is 110, probability of success is 0.25, probability of failure is 0.75. We calculate three things, that is NP, NQ, and NPQ. Now NP, remember, is the mean, and NPQ is the variance. NQ is nothing. So why do we calculate it? We calculate it because we should justify. So we should always justify whether the examiner asks for it or not, justify the use of normal approximation. Since NP is greater than 5, that's right over here, and at the same time NQ is greater than 5, therefore x now follows a normal distribution. What is the mean? 27.5. What is the variance? 20.625. NPQ is variance, NP is the mean. And then last but not the least, fewer than 22. 22 is not inclusive, so we have to do something known as continuity correction. Whenever we convert from a discrete probability distribution to a continuous probability distribution, whenever we go from binomial to normal, we have to do continuity correction. Now this value 22 cannot be used. The lower class boundary or the upper class boundary can be used. We draw two lines. Since we are going in the left direction, we choose the line that is not going over 22, that is not including 22, so that particular value is 21.5. The rest of the working is pretty basic. Standardize, get the z value, apply the rules of symmetry. So when it says z is lesser than negative 1.3, that is the same thing as z is greater than positive 1.3. That's what this rule says. And then when we talk about greater, if we are looking for this value, what do? We calculate this probability and subtract from 1. That is according to rules of normal distribution, and we get this answer. We get the z value to find the probability. So z to p, we apply the relevant rule and we get this answer. Part B. For a random sample of 10 residents of this town, find the probability that fewer than 8 classified their bus service as good or satisfactory. So good, let me just erase this over here. It's getting a little bit mixed up. So good is 25, satisfactory is 60. So 25 plus 60, how much is that? That is 85%. So we are working for 85%. That is the probability of success. So now 10 is the number of trials, 0.85 is the probability of success, fewer than 8 does not include 8. So I have used the symbol W for good or satisfactory. Probability W is lesser than 8. 8 is not inclusive. W lesser than 8 means lesser than or equal to 7, but that's too much to calculate. 7, 6, 5, 4, 3, 2, 1, 0. So what's the shortcut? That is calculate the probability for 8, 9, 10 and subtract it from 1. So applying the rules of binomial distribution, let me write the formula in case someone has forgotten. So I'll write this, that is x follows a binomial distribution n comma p. Probability x is equals to r for a particular value, that is NCR, success raised to power of r, failure raised to power of n minus r. So over here, what's the probability of success? That is 0.85. We are calculating for 8, calculating for 9, calculating for 10, and that is the power of the probability of success. 10 minus 8 is 2, that goes over here. 10 minus 9 is 1. 10 minus 10 is 0. These are the powers of probability of failure. Use the calculator, and you should know how to use the calculator in a nice, efficient way. You can put all of this thing together, calculate it once, and then subtract from 1. This is the final answer, correct to 3SF. Now the last part is also a good one, kind of a unique, but not anything difficult, because we have done things like this in class. 3 residents of this town are selected at random. Find the probability that 1 classified the bus service as good, 1 as satisfactory, and 1 as poor. So these are the corresponding probabilities for good and satisfactory and poor. Of course, they will be multiplying among themselves, but there are 6 ways. Now, how do I get the 6? That is the same concept as like arranging ABC. ABC, ACB, BAC, BCA, CAB, CBA. Basically, it can be arranged in 3 factorial ways. That comes out to be 6. So when there are 3 different scenarios like good and satisfactory and poor, so it can be arranged in 6 ways, just like I've arranged 3 different alphabets, and I get this answer, which is 0.135. Now the last question, I assume that is question number 7, that's of permutation and combination. And in this one, the classic question is this one, and I have shown the working in full detail. So now the first part is pretty basic. How many different arrangements are there of the 10 letters of the word regenerate? Whenever you come across a word in which there is a repetition of alphabets, letters, write it like this: REGENERATE. That means there are 2 R's, there are 4 E's, and there is GNAT. So this is 10 factorial because there are 10 letters, 2 factorial because 2 are R's, identical alphabets. Remember the concept, identical. Since they are identical, we divide by that many factorial, and 4 E's are identical, 4 factorial. This is the answer. Leave the answer in the exact form. Now this question is a nice one. The working is down below. Let me first read it out for you. How many different arrangements are there of the 10 letters of the word regenerate in which the 4 E's are together? The 2 R's have exactly 3 letters between them. Now I'm using blue colors for the 4 E's. They should be together in a box. And then there are 2 R's. They are kind of fixed, and we will have 3 letters between them. So 4 plus 2 is 6, 6 plus 3 is 9, 9 plus 1 lone wolf, that is this letter, that will be separate. Now what are the possibilities? The first possibility, let me show you all of them. So now the first possibility, just focus on this. That is 4 E's on the extreme left, and then R over here, and then this is also kind of fixed. Now the 3 letters can move around, but this R is fixed because these 3 have to be there, and this lone wolf is at the right hand side. Again, the 4 E's are on the left, and what I've done is that I have picked it over here and placed it over here. And then this thing is pushed on the side. So one possibility, another possibility. Now the extreme of this, these 4 E's are pushed over here. And let me label, I have left it over here so that you can also follow. Let me choose the thin marker. So this is R and this is R. This is that lone star, and then the 3 alphabets are right over here. Again, the 4 E's are on the extreme end, and I have picked this one and placed it over here and pushed this a little bit, just 1 unit to the side. So now this lone star over here, and then there is R, then there are these 3 tick marks. Now what is left? Think about it. I have taken 4 E's to the left, 4 E's to the left, 4 E's to the right, 4 E's to the right. I have played around with these 2, I have played around these 2. That means now the possibility is this. That means E is not on the so extreme. So now this is on the extreme, then 4 E's, then this 5 combination, and then this is on the extreme. This is extreme left, and this is extreme right. And then let me label all of them. That is the star. So hold for a second. That's the star. That is the star. These are the 3 tick marks. The 3 tick marks. There is an R. There is an R. And what you learn over here is to think out of the box. So there are 6 rows over here. And then ROWS, 6 rows. And then 3 and 1, 4 factorial for these. All the other ones are fixed. So that's how I'll write the answer. That is 4 factorial for the movement of these 3 ticks and this star. Let me even put the colors over here. So that is the green and the green and the green and the purple. That's right over here. That is the 4 factorial. And there are 6 lines over here. So 1, 2, 3, 4, 5, 6. We multiply it out and this answer comes out to be 144 ways. So that was also another classic question, 7B. Now let's focus on 7C. Now the question says that find the probability. That means we need a denominator. Denominator is answer of part 1. Why? Because that is without restriction. That is all the possibilities considered. So answer of part 1, 75600, that's the denominator. Now what are we doing? In which one is a consonant and one is a vowel. So now always remember that if I have 5 consonants and 5 vowels, and I'm interested in alternate arrangements. So it could be consonant vowel, consonant vowel, consonant vowel, consonant vowel, consonant vowel, or it could be vowel consonant, vowel consonant, vowel consonant, vowel consonant, vowel consonant, because it's an even number. And let's say, for example, if it was an odd number, let's say 3 consonants, 4 vowels. So the only alternate arrangement would be vowel, consonant, vowel, consonant, vowel, consonant, vowel. There won't be any multiplication by 2. Now, again, I have listed it out, 2 R's, 4 E's, G and AT, but this time the distinction is not based upon this thing. The distinction is based upon vowels. How many vowels are there? It's also written over here, A, E, 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 E. And how many consonants are there? G, N, double R, and a T. So 5 factorial for these 5 consonants. So let me write over here 5 factorial for the consonants, 5 factorial for the vowels, 2 consonants for arrangement, consonant vowel or vowel consonant series like this, and 4 factorial for the E's. So which color are they using? For the E's I have used, not they, I have used a green color, that's 4 factorial. And for the reds, I use 2 factorial like this. And let me just remove the rest of the colors from here. So over here, that's how this is done. This answer comes out to be 600. Therefore, the probability is 600 divided by 75600, 6 over 756 or 1 over 26. Leave the answer in the exact fraction form. Fractions are good. You don't have to worry about accuracy. So that's how we have completed this paper, which is May-June 2024 S1 paper, the second variant, which is known as variant 52. So I expect that you understand everything in full detail. I have tried my level best, and good luck for the exams. Take care.